Hello, everybody, and welcome to the SciLine media briefing on extreme weather and attribution, with an additional focus on wildfire science and what's known about the links between wildfires and climate. I'm Rick Weiss, Director of SciLine, and for those who haven't worked with us before, we are a philanthropically funded, editorially independent, free service for reporters covering stories about science, health, and the environment. We are based at the nonprofit American Association for the Advancement of Science in Washington, D.C., and our funders care about really just one thing, getting more solid, reliable, methodically derived scientific evidence into news stories. We help do that primarily in three ways. First, when you're working on a science-related story and you're having trouble finding just the right expert to help explain something to you or provide some evidence-based context, we have a large database of knowledgeable, articulate experts to whom we can connect you. There's a small form on the website that will get you there. Second, we produce fact sheets on various science-related topics in the news, fact sheets that are specially designed to be useful to reporters who are insane on deadlines and just need the essentials fast without a lot of blah blah. We research and produce them in-house, and then they're vetted by multiple outside experts before we post them, so you can count on them being accurate. And finally, third, we host media briefings like this one today to get reporters up to speed on topics in the news around which there seems to be some misinformation or confusion. Today's topic certainly fits that category. There's been a huge amount written lately about extreme weather and about wildfires, and there's been a growing amount written about the media's failure to appropriately explain the links between these events and climate change, with some stories focusing solely on the events and not even mentioning climate change, and others overgeneralizing and seeming to suggest that every fire and flood these days can be blamed at least in part on climate change. The truth is, it's a little complicated, but it's not that complicated, and you can, without very many words, squeeze the actual facts into your stories without understating well-established connections or overstating weaker connections. And to help you do that, we have three extremely knowledgeable people with us today. Their bios are on the landing page that you all came to, so we're not going to take time to go through their credentials right now, but we will hear first from Marshall Shepard of the University of Georgia, who will get us through some basics about extreme weather and climate, and then from Stephanie Herring from the National Oceanic and Atmospheric Administration, who will take us a little deeper into some extreme weather event specifics, and finally from Tim Brown of the Desert Research Institute to talk about wildfires. After their presentations, we'll open it up to questions for the rest of the hour. So without further delay, Marshall, please go ahead and get things started.
Thank you. And I want to just start off by thanking all of you for joining. This is an important topic. It's often a misinformed topic. It's often a topic that gets lost in the milieu of the social media tennis matches that I often see going around, where you'll have an extreme event and you'll have someone saying, oh, here they go, saying everything's caused by climate change. And then you have the other side saying, well, of course this is related to climate change. So I think today's SciLine effort is really important, and I'm glad to see so many media involved. I want to start off with the bottom line up front in terms of extreme weather and climate change. I served as one of several authors on a National Academy study on extreme weather attribution to climate change. That report is available at the National Academies. Also, AAAS and SciLine have provided some very good fact sheets. Let's start here, a definition of weather and climate, and I want to start there first. Weather is sort of our day-to-day atmospheric conditions, whereas climate is really the statistics of the atmosphere. So I start that off because how many of us have heard on a snowy or a cold day, oh, so much for climate change, I've got 20 inches of global warming in my yard. Well, we know that that person that says that doesn't necessarily understand the difference between weather and climate. And so when we talk about extreme weather and climate, we have to then broaden our understanding and discussion to make note of the fact that, yes, every extreme weather event that we experience here on the planet, whether it's a hurricane, a heat wave, or a flood, has happened irrespective of climate change. But the key point to note is that even with a naturally varying process, we can have a human amplification on top of it in the same way that a home run hitter in the major leagues can hit home runs naturally, but in the steroid era, they were hitting longer and more of them. And so this notion that it's either or is flawed. It's either we have extreme events because of natural variability or we have extreme events because of human contributed climate change. That's a flawed narrative. It's both. Grass grows naturally, yes, but when we fertilize the soil, it grows differently, and that's how we have to think about that. So now if I can get my first slide, which is the bottom line up front, with the this was one of the most robust studies done to date on extreme weather and climate change attribution. And from that National Academy study, the bottom line right up front is that we found that it is indeed possible to estimate the influence of climate change on specific extreme events. And the ones that had the strongest signal in terms of our ability to understand the physical processes, our ability to have ample observations, and the ability for climate models to represent them in the models, those are the three pillars that we use to establish our confidence in these. The three or four that came to the top were heat waves, the lack of cold events, drought, and heavy precipitation increases. And so this is very important, heat waves and heavy precipitation, to what we're going to be talking about later with wildfires. I'm sure Tim Brown will talk all about this. The notion that we've had extreme rainfall in California and we've had extreme drought. Both of those are factors, perhaps, in the extreme fires that we've been seeing in the past several months. It's the notion that the extremes will become more extremes. That's what the scientific literature always hinted at, and so that's what's manifested. So we get more extreme rainfall, perhaps, you get more vegetation and fuel load, and then you have a drying period, then the drought, and all of those things conspire to lead to perhaps wildfire intensity, but I'll let Tim talk more about that. I want to make sure that the media is asking the right questions. The way attribution questions are posed influences how they are answered. And so if we can go to my next slide, this is also a very important finding of that National Academy study. We have to move away from this notion of, was that event caused by climate change? That's an ill-posed question. Better questions are the events of this severity becoming more or less likely because of climate change, or to what extent is it more or less intense because of climate change? I think that gives us a better framing. I often talk about baking cookies. If you bake a cookie, depending on how much sugar or flour or chocolate chips you place in your recipe, you're going to get a slightly different cookie, but it's going to come out looking like a cookie. In terms of our climate system, we're always going to have the naturally evolving weather processes that we're all used to, but with the backdrop of this baked-in climate change from human-caused emissions, in part, and also land cover changes and some other things that I know some colleagues would also want me to talk about as well. We get this sort of different cookie. It looks like a cookie, but it's amplified in a different way. So it's important to understand and ask the right questions when you as media are coming to us as experts about how to frame the question. And then my final slide really gives you a look at the sort of a synthesis of the results of this National Academy of Sciences study. So we found that the lack of cold events is a very strongly attributable signal to climate change. Did you guys notice this past winter, it was the news. We had winter. We had nor'easters. And so there was all of this news about it because we've had so many winters that were not relatively cold or didn't have the winter storms that we talked about. So I actually found it quite amusing that we actually had a winter this year, and it was being covered in such a way and used by certain groups to say, see, climate change is, well, we just had winter. And so that the fact that we have such a rare occurrence of these sort of extreme cold events now, that was really led the findings of that report. The report also said that many of the extreme heat waves that we're seeing around the globe have a very strong attribution signal to climate change. Drought, extreme rainfall events as well also ranked higher on the list of certainty and our ability to understand their linkage to climate change. Now I want to explain some of these that look like they fall lower on the scale. For example, you might see fire down there on that scale. And I think Tim will talk about this and others as well. it's not that we don't believe that there is some perhaps linkage to climate change and wildfire activity, but there are many other sort of factors involved in both fire and flooding, which you don't see on this list as well, that are related to human management, decision making, and other things that are not necessarily related to the evolving atmosphere. So when you see something like tropical cyclones or fire down lower on that list, that doesn't necessarily mean there's no link to climate change. It means based on those three factors, understanding, reproduction in models, and observations that we have going back a certain amount of time, they rank lower at this time based on the peer-reviewed literature. So hopefully that gives you a backdrop of some of this extreme weather and climate attribution. Attribution is a new area of study within climate. Get used to it. You're going to hear more about it going forward, and that's why I appreciate what SciLine is doing today by having this forum, and I'll stop there.
Thank you, Marshall. Stephanie.
Thanks, Rick, and thanks to Marshall for providing some of that context. You know, sometimes attribution results, there's a real desire, I think, to be able to communicate them in this binary, yes, climate change played an influence, or no, it did not. And I think that when you see that, you know, the plot that Marshall showed in his last slide and the three pillars that he mentioned, really those are important because what we're trying to get at here is not just this binary yes or no answer, but really an ability to drive towards the quantification of that impact and to be able to communicate what level of confidence we have in what we think the change in risk of an event might be. And so, you know, the three pillars example, I'll dive a little more deeply into it. So for heat, and one of the heat and cold, one of the reasons they are so high up there, of course, is we have a great observational record for heat, in particular in North America, but that may not be true in other parts of the world. And so when we look at even heat attribution statements, say for United States versus perhaps other areas like Sub-Saharan Africa or South America, where the observational record is not as strong, and as we have it here in North America, the ability for us to have confidence and where events might actually fall on that plot that Marshall showed varies not only on event type, but event location as well. And so that's another important piece of context to remember. And another example that I like to point out often is the example of tornadoes, which isn't even on the plot that Marshall showed. And that's because, of course, we have a very poor observational record from the climate context. Certainly as a weather event, in particular now, we have good records of tornado intensities and tracks. That wasn't always the case. And so relative to an event like heat, that observational record is very short. The models do a very poor job of replicating micro events like tornadoes, and we actually have very little understanding of how we expect climate change to impact tornado intensity or frequency going forward because of all the different drivers that go into a tornado event. And so it's particularly important to remember that when we're talking about different events, that it's not just, again, this sort of yes or no answer, but with what level and what degree of confidence or certainty can we make these statements about how much the risk has changed. And that's really where attribution science is headed and where our focus has been. The BAM's Explaining Extreme Events report, which I helped edit, is focused on that. We do not ask the authors for a simple yes or no answer. We ask the authors to really focus on what is the change in risk that you would expect and what's the level of confidence that you have in that statement. And so, for example, we have looked at events like Hurricane Sandy, where we saw that the storm surge, not the hurricane itself, but the storm surge from the hurricane was found to have been made more intense and larger because of human influences on the climate, in particular related to sea level rise. And again, the precipitation associated with Hurricane Harvey. Several studies now come out to show that not the storm itself, but the intensity of the precipitation was made more intense because of climate change. And so here are two examples where, because of the event type that we were looking at, again, not the hurricane, but either the precipitation or the storm surge associated with it, they were able to go in and look at that and not only say, yes, it was impacted by climate change, but come up with estimates of how much more intense or how much larger the storm surge was because of climate change and what that would mean for the future. And those are the results that then can be used by decision makers looking at, okay, well, what's my likelihood of having Harvey-like precipitation in the future or Sandy-like storm surge in the future? And those decision makers now have better information to go forward and think about what is it they want to do related to adaptation or resilience and other variables. And that's one of the real values of attribution science. There are always, of course, studies that do not find a role for climate change. So, for example, speaking of snowstorms, 2016 snowstorm Jonas, which caused over $1 billion in damage, the authors did not find a link to climate change in their work on that. Now, what does that actually mean? As Marshall said, when we saw things in the lower left-hand quadrant down there, it didn't mean that climate change isn't playing a role. But given the strength of the pillars that we have today for events like snowstorms, in this particular location, the research team couldn't make a conclusive statement that climate change played a role. Does it mean that it didn't? Possibly, but there's also factors such as perhaps as those pillars get stronger over time, that we will actually be able to see a climate change signal in the future. And so as the tools that we have as a research community get stronger, the observational record gets better, the models get better, our understanding of the physical processes get better, these events that were previously found to not be impacted by climate change, a retrospective study may find something else. And that's an important context to remember when you hear about an event and one particular group may come up with one result and then you hear something else from another group. The results may not necessarily be conflicting. They perhaps took a different methodological approach. If they were in different time periods, perhaps different groups had different tools to work with. And so that element of how attribution studies should be interpreted is important to remember, that different methodological approaches may or may not yield different results. And finally, in 2016, we had something kind of interesting happen, which was we had 3 events that were found to quote unquote be not possible without climate change. And so there was a lot of discussion about what does this mean? From a statistical approach, what they found was that using models of a world that we live in with climate change, and then a model of a world in which theoretically human-caused greenhouse gas emissions have not been occurring, and climate change as we know it has not happened. And by comparing the two, they literally could not replicate the event in a world in which human-caused greenhouse gas emissions had not occurred. And so that's what, from a scientific perspective, not possible means. So how do we explain that? Really what we're seeing is that we think climate change is now pushing events beyond thresholds that natural variability alone could not have pushed them. And so this is this question of, was an event quote unquote caused by climate change? I still hesitate to say that because natural variability still played a role in these events. It still likely would have been a very warm year in 2016, regardless of whether climate change was a factor or not. But would it have been could it have been as warm as it was without climate change? The research is pointing to the fact that perhaps it could not have been. We would not have crossed that threshold without human-caused climate change. And so there's a sense that we are now approaching new weather regimes because we have created a new climate on this planet. And I will also say that climate change still, again, I want to reiterate this very importantly, does not act alone, as Marshall said. Natural variability is still a player in all of these extreme events. And the question we're trying to look at is, what role is climate change playing? How large is that role? So where does that leave us? Again, when trying to communicate the results of attribution research, as there's probably a reason that this has been a challenging area for the media, and it's in part because, as Marshall said, it's important to focus on the right question, and I think that is sometimes difficult to tease out from some of these complicated scientific studies, and that's where people like SciLine and what Rick is doing is so important, is because they do try and distill down some of this complicated research into understandable messages. But this issue of the right question is a very, very important one. I think also understanding how the extreme event is defined, so what type of event are you looking at and where did the event occur, will impact what confidence we have in the results. And so it's something to just keep in mind as you're thinking about how to talk about these events. And then finally, I think it's really important to be prepared for change. So what do I mean by that? If we had been giving this briefing, I'd say a little over a year ago, we would not have been talking about these events where they were not possible without climate change. And up until then, for over a decade, scientists have been saying every event could have happened in a pre-industrial climate. And now we're actually questioning whether or not that's true. And of course, these are just 3 studies that we saw in 2016, so there's still a lot more work to be done, but it seems that we may have passed some type of threshold where perhaps these events were not possible in a pre-industrial climate. And so That's been a major change in our understanding of how we communicate attribution science. Again, if you had asked us perhaps even 10 or 15 years ago, you would have had people on this panel potentially saying that this field of research is impossible. So this is a rapidly changing area of research, and looking ahead, for instance, one of the things that we're seeing is how quickly people are willing to come out with attribution statements. So Germany, for instance, is now working on coming up with real-time attribution statements. Shortly after an event, for instance, they are talking about potentially using social media to put out an initial communication and then following up with some kind of attribution study within as little as a week or two. And so that, again, is a huge change in the field. No one would have thought we would be here 5 years ago. People were thinking about it and talking about real-time attribution, but it still seemed quite a ways off. And so the fact that Germany is embarking on this is something that will be interesting to watch. And then finally, I think that looking ahead, as Marshall mentioned, and this is something that I will so certainly be saying today, this idea that there's natural variability that kind of, lets events happen and it's always a player. And then there's some kind of clear line, and that over that threshold is where climate change pushes events. I think as research continues, we're going to find that potentially some of these factors that are natural variability, like the ENSO cycle, for instance, which we still put in the natural variability category, and I still put in the natural variability category. Research is emerging that perhaps even these natural cycles are being impacted by climate change. And so that in the future, are we going to be able to draw this clear line between saying this is the natural component and this is the climate change component? That, I think, that clear line is going to start to get grayer and grayer as we find that some of these natural variability, the natural drivers of these meteorological events are themselves being impacted by climate change. That's research that's yet to be done, but I do think that, in my personal opinion, I don't want to speak for anybody else or my co-editors in the DAMS report, I do think that's an area that we're going to need to keep our eyes out for in the next certainly 5 to 10 years. And so there's been a lot of change to date, and I certainly expect to see more change in the future. I don't think we've stabilized yet as a field of research, and it's very exciting. I hope that as a media community, you stick with us and wait to see what we discover, because I think there's a lot of important discoveries ahead to be had. Thanks, Rick.
Great. Thank you, Stephanie. Very interesting. Tim, let's talk about wildfires a little bit.
Thank you, Rick. Good day, everyone. Yes, wildfire is in the news, not just here in the U.S., but globally as well. So I will follow up on a few points, too. It was nice that Marshall and Stephanie talked about the attribution and weather and climate differences, and that helps set this up a little bit. Maybe some definitions, just to be clear on those. Wildfire, for example, that refers to the uncontrolled vegetation fire, and it really is the best term to talk about fire on the landscape in general. Sometimes you'll hear forest fire, or that term is used, but that really should be reserved explicitly for fire in forests, such as grassland fire is, say, for fire in the prairie regions. Another common term is prescribed fire, which is any fire intentionally ignited by management actions in accordance with applicable laws and policies and regulations to meet specific objectives. So then wildland fire is any non-structure fire that occurs in vegetation or natural fuels, and it actually includes both prescribed fire and wildfire. And area burned is another common metric that's used to describe the spatial extent of a wildland fire. And notice there I say wildland fire because I'm talking about both prescribed and wildland. But by itself, it says nothing about the actual impact, and its usage related to wildfire often implies a destructive nature, but this is not always the case. In various ecosystems, it can have these different levels of high severity or low severity, but yet would get counted as a total area burned. A little bit just on climate versus weather. I like to think of climate as enabling fire and weather as driving fire behavior. Climate is certainly an important factor in establishing the vegetation types on the landscape. It describes the accumulation of weather within monthly, seasonal, and longer time scales. Marshall mentioned this. For example, seasonal or anomalous longer dry periods can reduce fuel moisture, allowing for increased ignition potential. But wet periods allow for vegetation growth and accumulation, and so thus climate is an important factor in the cycle of fire. And the Napa Valley fires was a good example of this, where extreme precipitation in the winter and spring allowed for extensive fuel growth, and then when that dried out later in the fall, it became very flammable and susceptible to ignition. The shorter-term weather, temperature, atmospheric moisture, we usually think of it as relative humidity, and wind are then the drivers of fire on the local landscape. Another term I've been seeing a lot of reference to is fire season length, but when I see that, it's almost never defined, and there can be numerous definitions. I prefer to think of it as the period dominated by high fire danger and likely to have the most rapid increases in fire spread. So it's really a weather and climate dominated definition. So where are these fires coming from? If we could put up that first figure, figure 1, this will show from a recent research paper the distribution of percent of humid ignitions across the U.S. And basically 80%, a little more than that, of wildfires are human started. And they also represent about 60% of the land area where ignitions occur. The reddish areas, of course, also highlight high population areas. And the blue areas there in the west, representing the interior west, are fewer humid ignitions, but they will be higher lightning ignitions. And we can see that in the next figure, which shows the distribution of lightning-caused fire by season. The different colors indicate that. Not surprisingly, most of the lightning-caused fires occur during the summer months, June, July, and August. And in the west, the human-caused fires are also occur a lot in June, July, and August. And of course, this is largely due to recreation activities, people out doing camping and visiting parks and that sort of thing. So there is a high correlation between where people live and are active and human-caused ignitions. So another question that comes up is this season the worst season? How does it compare to past years? And this is worthy of actually for further assessments because, for example, we really don't have a simple real-time kind of index to make that comparison. For example, the number of fires, we don't really use that as a comparison. While this number does vary annually across the country at around 70,000 a year, if anything, that number has actually been on the decline given effective fire prevention programs and increased public awareness about the risks of fire. Area burned, which I mentioned before, is the most common metric for comparison, but by itself is not a good measure of the overall impact. A better way to get to that is fire severity, which is the degree to which a site has been altered or disrupted by fire. And loosely, we think of it as the product of fire intensity and the residence time. So the strength of fire in terms of its energy and how long it's been in that place. The extent of fire severity may be and is often documented at a post-fire local level, but that may take a while to actually get that information in terms to make any kind of historical comparison. But there is, for large fires greater than 1,000 acres, a national data set of severity that's derived from satellite observations, and those results have appeared in a number of science papers. There is a trend, especially in the West, for increased area burned for large fires, but because of this data set, we can also look at fire severity, and so there is a weak increasing trend given the official definition of what fire severity is. Home destruction is an increasing metric related to wildfire, and this is largely due to human expansion into areas that are historically fire-prone. For example, in California, 6 of the state's most destructive wildfires occurred last year, and here in 2018 combined. So an objective measure is difficult because human factors are so closely tied to fire. There is one other indicator that the Fire Management Agency uses. It's called the Preparedness Level. It's on a scale of 1 to 5, and each level describes needed amount of firefighting resources that are being utilized or will potentially be needed. Nationally, it has been at level 5, the highest level, for quite a while now, and probably even started maybe a little earlier than usual. But for California, where so much of the news has been coming from, it's actually at 4 at the moment. So despite everything that's going on, this level is not at its maximum point of where it could be. So talk about just then climate change a little bit. Marshall mentioned this very nicely to say that climate change causes a single fire. It's not really accurate because it ignores the other factors that allow for fire. Certainly warming temperatures and related drying in terms of increased fuel aridity is a major component of fire, but so are land management practices and the public desires of what we want on the landscape. Historical aggressive suppression in many places is allowing more intense fires to burn now instead of the historically low intensity and forest regenerating natural fires. And as I said before, people have increasingly moved into natural fire-prone areas, and without building and landscape codes, fire mitigation is, having fire mitigation makes these places more susceptible to the damaging effects of wildfire. So I think of where we're at today as a convergence of climate, people, and fuels. They are all very closely tied together. And as one example of that, people are warming the planet that enables more fire, and people are responsible for starting most of the fires that cause most of the damage. So it's a full circle. So where are we at in terms of predictions and what we think we know about the relationship between climate and fires? Certainly hotter days and warmer nights leads to drier fuels, so that's a factor. Once fires happen, a disturbance, there's very much a potential role of invasive species, including insects, flammable grasses, and even monocultures at a single species moving in and minimizing the diversity of a landscape. Possible that there might be more convective storms, meaning more lightning. I would say this is low confidence at the moment, but more scientific studies should be looked into for this because it is a possibility. A lot of times you'll hear about snowpack leading to more fire, but this is not actually so clear a relationship because wildfire is also strongly influenced by what happens from the weather between the snowmelt season and when fire occurs. So for now, climate change is really manifesting itself primarily through changes in the character of fire rather than the frequency. And around half of the increase in area burned in the western forest fires, and here explicitly I'm referring to forest fires, in recent decades can be attributed to long-term warming trend. And so that's one of the very few maybe direct attribution studies that have come out in relation to climate change and wildfire. But vegetation of all types is becoming more flammable, and this also means if you have more high-intensity burning, you'll get more smoke and the potential for human health impacts. Now, what does this mean for fire management? Well, they're having to change tactics for these larger and more destructive fires by focusing on more point protection, that is the homes and structures, and also trying to guide the fire to places where it might be more directly controllable. Suppression expenditures are very much on the rise. but I think it's important to keep in mind that the wildfire problem is not really a scientific or technical dilemma. It's really more of a political and societal challenge. And limiting the severity of the wildfires, even as climate warms, should be a primary overarching goal. There is little capability in predicting when and where fire will happen. However, short-term forecasts and monthly seasonal outlooks of fire potential are largely successful in indicating places where fires may be problematic, giving firefighter agencies an early warning. Fire spread models are largely statistical based. They're widely used, but we really need a lot more research and development to advance the physics modeling of the wildfire spread aspect. So just to summarize, I think we should all be careful about throwing around terms like the worst fire season without really defining what that means. We want to try and relate to, or we should try and relate the specific connection of climate to the fire activity being described, rather than just generally saying climate caused it. As I mentioned, the best documented climate change attribution we have at the moment is warming and its relation to fuel aridity. And it's also important not to overstate the state of knowledge or modeling activities and remind the audience that most fires are human caused, and so there's a role there that we can also increase prevention. All right, thank you.
Great, thank you, Tim. Again, to remind folks, if you have questions, you can type them into the Q&A box, and we'll pick them up and give them to the speakers. I want to also note that if it wasn't clear from the beginning, this entire briefing is, of course, on the record, and in fact, the entire video and a transcript, a timestamped transcript, should be up within the next day or so for people to refer to. While people submit their questions, I just want to throw one out to maybe Marshall or Stephanie. As it becomes more clear that we can move away from this general association saying climate change is leading to an increase generally in heavy rain and heat waves, and we know that those are a little bit more attributable than maybe other things like fires, and towards being able to specifically attribute this particular event was 300% or 400% more likely because of climate change, or maybe even couldn't have happened if not for climate change. Maybe one or both of you could quickly address the question of why we want to know. You know, if the Germans are going to be providing almost a weather report, but it's an attribution report saying, yeah, this storm that just happened, that was 3 times as likely to happen because of climate change. What's the point other than finger pointing? There's a reason why we want to know this, right?
I'll defer to Stephanie.
Sure. So I think that, as I mentioned, one of the main focuses of the BAM's Explaining Extremes report, and why it was originally started actually, was to really advance the methodology. And one of the main focuses was how do we quantify the change in risk and improve our certainty around those quantifications. So I'll give an example from the 2016 report of this area that's emerging now, which we're calling impacts attribution. And I think that this is, for me personally, one of the more important values in having that quantification is that, as I mentioned in my previous comments, the relationship, attribution science is sort of great. It's like, yeah, here's a finger pointing, but what do you do about it? And what kind of adaptation and resilience activities can be taken? As the climate science community, we're not, in that decision-making position. But ideally, climate science is a seat at the table for those decision makers, so we can provide them with information that says, within Hurricane Harvey, and as you start to rebuild, this is the likelihood of this event happening again. And certainly there will have to be things such as, well, how much is it going to cost to rebuild, and how much is it cost to rebuild to a new standard, that have to go into that decision. But without having some sense of this is the likelihood of that event happening again in the future, it's difficult to simply take these binary yes or no answers and do anything about it. If someone tells you it's going to rain tomorrow, does that mean it's going to rain a little bit, but I don't really need to bring an umbrella, or I'm going to have a flash flood warning? Those are two very different pieces of information that as an individual you might take and take some kind of action against or not take action against. And so it's really the ability to provide an understanding to decision support the decision support community as to here's how we think your risk is actually changing due to climate, and they can then layer that into all the other variables that go into any other type of adaptation or resilience decision. But it's another piece of information that they can be using.
I wanted to follow up on that quickly because another piece that we briefed congressional leaders on after the National Academy's report is that from attribution activities, there is a goal perhaps to provide predictive or probabilistic forecasts of future extreme events at lead times of days to seasons or longer. And so the more we understand about how some of these extreme weather events are emerging within the backdrop of this sort of elevated sort of climate forcing, if you will, that actually can perhaps provide guidance on future predictive capabilities at scales longer than 7 to 10 days, which is the typical weather forecasting scale.
Cool. Here's a question from Benjamin Spillman, Reno Gazette Journal. He's saying, Dr. Brown, you said half of increase in western forest fires can be attributed to long-term warming. Can you please elaborate on that point? Tim, you might be on mute.
Sorry, yes. This is referring to a paper that was in the Proceedings of the National Academy of Sciences in 2016. It is referenced in the fact sheet that was sent out. Basically, that paper describes warming in the western U.S. in its relation to area burned in forests, and the fact that temperature is strongly related to atmospheric moisture, which is related to fuel moisture. So they looked at 8 different indicators of drying for fuel aridity and showed through that the warming in relation to the drying of the fuels was responsible for an increase of half the area burned in these western forests in recent years.
Great. And the fact sheet that Tim just referred to is the SciLine fact sheet on wildfires, which is available at our website, sciline.org/evidence. And we have a question here from Doyle Rice at USA Today. Is there a good source of how many severe wildfires there have been year to date, similar to the National Interagency Fire Center's running total of acres burned and number of fires, since severity, you've mentioned, is a better metric?
Yes, and not really, not one that's very easily or publicly accessible. It is that satellite-derived data set that goes back to the early 1980s and is more or less up to date. So no, we don't have a good readily available index for the public in terms of severity at this time.
Question from Seth Borenstein of the AP. Which is more important with regard to the increase or the status of forest fires going on, wildfires going on, precipitation versus temperature? That is to say, I think lack of precipitation or drought versus temperature increase. Is it possible to rank those?
Possibly. I know some climate scientists who work in fire would say that temperature is more important because, again, the warming leads to drying of the fuels. And this would be particularly so up in northern environments, boreal forests. So we're talking, if we're thinking of this globally. And also, I think, given that Proceedings paper and the work that was done there, leading to the fuel aridity, temperature would rank very high. But again, precipitation, if you go into drought situations, that allows for fire potential. But also, as was mentioned, if you have very wet periods, this increases the fuel growth and amount of fuel available.
Yeah, I want to just kind of quickly follow up on that to Seth as well, but I think one of the things that for me jumps out about this is that it's both ends of the extremes that play a role, and one of the things that is crystal clear to us as climate changes is that the intensity and perhaps frequency of the extreme aspects of the hydroclimate, meaning rainfall and drought, will increase in intensity and frequency. And so if you think about these distribution curves, these Gaussians and these probability distributions, if you're shifting those curves towards the likelihood of more extreme drought and rainfall, then that really suggests that will lead to some of these sort of aridity and fuel loading scenarios that we're seeing. I try to give you, Seth and others know me that talk to me I try to give very clear sort of human examples. And if you're adding 1 foot to the basketball court, even I, at 48 years old, can now dunk a 10-foot basketball. I might not be able to with a 10-feet one, but if I add a foot to the floor, I bet I can get it. And so, if we're continuing to add to these extremes, given what we know in the literature, that suggests that this is something we're going to be dealing with.
Great. This is a question also from Seth, but for Stephanie. I'm not sure if this is something you can get, Stephanie, or whether you want to punt to Tim, but he's asking, since you mentioned you can't quantify the increased risk for this specific fire season due to climate change, can you give us some kind of qualitative sense of how risk has changed due to climate risk, again, risk on wildfire?
Well, I think Tim started to answer that question in his previous, so I will punt back to him. But I will also say that there have been attribution studies done on particular fire seasons. Tim was talking about a more comprehensive, sort of longer timescale attribution study in that Proceedings of the National Academy of Sciences paper. But for instance, in let me get my years right, I believe in 2014, Alaska had a particularly bad fire season, and there was some attempt to do some quantification for that particular fire season, and they looked at 34 to 60% increase in risk. So again, there have been some efforts to do that. I will also say that the region, and again, this is where the question matters, the region in particular for these fire seasons matters quite a bit, and because in my experience, when I've seen individual attribution studies done for a particular fire season or a particular fire in a different location, because of all the different variables Tim talked about that go into a fire, different areas use different models to understand their fire risk. And so the papers in Alaska, for instance, were using something called a buildup index. People in the drought papers that I've seen on fire risk in California tend to look more at a drought, using a drought and precipitation metric. I've also seen papers come out of Australia that usually have a different type of modeling approach that tries to account for that local influence of that particular region where the fire happened. So, but Tim, I don't know if you have anything you want to add to that.
No, thanks, Stephanie. Yeah, that was good to bring those up. Maybe what this does remind me of, though, is that in the past, back in the early 1900s, and particularly, say, in the 1930s, when we had a lot of fire, a lot of large area burned, the conditions were, those were big drought periods, warm temperatures. So we know that the warmer it gets and the drier it gets, the more susceptibility to fire there is. And so in some ways, what we're seeing now with these large area burns, if we use that as a metric and trying to compare that to what we know for earlier years, we're really coming back to a period of very large fires, more extreme fires because of where people are involved in the home destruction. But the fact that it is very likely that this is a trend now that will continue and strengthen as we go forward.
We have a dual question here from Benjamin Spillman in Reno. Actually, one of them is asking Stephanie to actually list the three events from 2016 that have been now said to have not been possible or likely never would have happened without climate change. I can just tell you, Benjamin, that those are listed on the fact sheet, the SciLine fact sheet here, so it might be simplest just to see them on the sheet there. But the second half of the question asks whether that kind of statement has been made yet about anything having to do with fires. Can we say that the intensity or the number of fires happening now perhaps could not have happened without climate change? My understanding from what I'm hearing Tim and others say is that climate, because fires are so influenced by other factors like forest management practices, it's a lot harder to get a firm grasp on whether a fire would have happened or not. But Tim or Stephanie, do you want to pick up that question of whether we can say at this point that there are either some fires or the number of fires or the intensity of fires simply would not have happened according to models if not for climate change?
So I've certainly never seen any research that makes that statement, but Tim knows the literature better than I do, I'm sure. So.
No, I haven't seen anything specific to that either.
Yeah, and I would add that's why fires did fall lower on that graphic that I showed earlier from the Academy study. They're just various factors beyond those three pillars that we talked about earlier. And I think that's important. I think that's what maybe the public and maybe even sometimes our colleagues perhaps they're trying to convey to the public. It's a tough problem because we're not sitting here saying that climate change is not a part of these fires or may not be related to these fires. But it would be disingenuous, I believe, and I think my colleagues would agree to say that a particular fire this season is absolutely because of climate change. Can't say that, but we clearly know climate change is happening. We clearly know there's a human imprint causing it, and it's very likely that the environments or the extremes being caused because of climate change on the wet side and the dry side will lead to a backdrop of more more fires. But the specific attribution on an event basis, I haven't seen anything published on that, and frankly, it might be a bit careless to do that.
We have a question from Caterina Zimmer. She's a science reporter based in Germany, and it's a good general question that I'd encourage any or all of the three of you to address, and that's just asking you, what have you seen in the news coverage of climate and extreme events or climate and wildfires that you think the reporters could have done better, and maybe any examples of the kinds of coverage that you think were excellent and on the mark? What are the you don't have to name bylines, I guess, on these stories, but sort of high points and low points in terms of the kind of coverage you've seen of this somewhat complicated relationship. Stephanie, do you want to start? Or Marshall, go ahead.
I was just going to say the one that still to me that I see quite a bit of is just the cause. Was that event caused by? I think we just have to, I even wrote something in Forbes a couple of years ago saying we have to get that out of we have to just make it go away, make it go extinct. Was that storm or was that fire or was that flood caused by climate change? I think that is the one big thing that still kind of drives me nutty when I see that in the literature. I think one of the things that I am encouraged about, and I hope our media colleagues will continue to do so, I think with all the negative discourse about climate from U.S. pulling out of the Paris Agreement and others, I think there's more discourse and chatter about climate change now than I've seen in the past 5 to 10 years. There certainly could be a lot more. I would just suggest that there are opportunities to cover climate. I know there's always the need to have a peg or sort of a newsworthiness angle, but I think that the tendency for the public to sort of see just the coverage of the big events creates some kind of a selective bias, perhaps, or selection bias for the public. So, if we can get a bit broader coverage, and I know several of the people that I'm looking at their names on this list do this, if we can get a broader context of climate and how it's affecting people's kitchen table issues, So not just that, oh, it's hot again, or we broke another heat record, but, oh, we broke another heat record that's causing perhaps more intense or frequent drought in the Midwest. You might pay more for your Cheerios or your popcorn this year. So this sort of linkages back to the sort of kitchen table. I'd love to see more of that.
Great point. And I think on the cause, the cause issue, even when these instances come up where scientists are determining this would not have happened if not for climate change, even then it doesn't mean climate change, at least solely, caused the event, right? Many things always add up to every event, even if climate change was, in a sense, the last straw in some cases.
Yeah. Absolutely, but I think I want to get back to something Stephanie did say, though. We are not, I don't want the media here to leave this presentation with the scientists did it again, they're waffling, they can't really say, which is perhaps what may be being perceived by some. I think there are some very clear things that we can say about attribution of extreme events in climate change. Just be a bit careful about the nuances, the definitions. I think that Tim talked about another thing. But I think we, and Stephanie mentioned this, we have moved from an era 5-10 years ago to a point now where we're very comfortable saying some things about extreme events in climate. I just want that message to come out, ring out.
Stephanie, you want to make a couple of last points here as the hour comes to a close?
Sure. One, I think actually, is that despite how rapidly this field has changed, we, the scientific community, have not made it easy for, the journalists out there, I don't think. But that being said, I think they do a great job. In general, from what I've seen, especially in the past couple of years, I've been, in particular, some of the coverage for the report of the BAM Explaining Extreme Events report. I think in general, the media is working incredibly hard to get this right and doing a good job of communicating an incredibly complex, nuanced area of science. So kudos to you guys. The other component I think that I think we could do more to improve is to try and get some of the, see if we can move a little bit from this binary, yes, there was an influence, or no, there wasn't, into this is what we actually think the change in risk is going to be, and that quantification component, because I do think it's very important. And again, as Marshall said, we've moved away from this question of did climate change influence the event, the yes or no. We're really good at actually saying when yes it did influence it or no it didn't. It's the real crux for I think the research community is how much was that influence? What do we expect to see in the future? What's the predictive capability of this? And we're moving in that direction. We're moving very quickly in that direction, and so it would be exciting to see more of that get communicated in the media.
Thank you. Awesome. Tim, any closing words?
Yeah, I think that was great what Stephanie just said, and I suppose just quickly, particularly when we talk about fire, is to talk about the human role in fire as well as the natural climate role in fire, to make sure that picture is painted that it's very closely linked and connected, and that humans, people have a place in also preventing this, mitigating against fire, and adapting to these changing fire environments.
I think that's a great point to end on, to remember that there are things people can do to reduce these risks, whether we're talking about fire or some of the other impacts of climate change. We shouldn't forget about solutions, even as we talk about being ever better at qualitatively and quantitatively defining what the problems are. I'm sorry we couldn't get to the rest of the questions that are on the list. I do want to point out to people a last time that, again, if you go to SciLine.org, look at the fact sheets, 2 fact sheets that we've got up, one on attribution science for extreme weather events and one on wildfires. The answers to many of the questions I see coming up in the queue are there. These are quite succinct fact sheets. They're meant for reporters who are in a hurry. I think if you read through those, it'll take you 5 minutes, and you will have at your fingertips some great factoids that you can drop into your stories to have some real solid evidence plugged into your stories on these topics without having to work very hard. So I want to, just in closing, thank everybody for participating, thank our panelists for participating, for all of you reporters for logging in. I encourage you all to follow SciLine on social media at Real SciLine and to track our activities going forward. And with that, I will close this media briefing. Thanks all for participating.